where this is the net reactance. And when you are talking of the circuit which is inductive or inductance XL is greater, or you are having the value of RL series circuit, say for example, so we will be writing R plus J of XL, that is inductive reactance. And when you are talking of capacitive, we will write minus TXC, and this XC will be capacitive reactance. Clear?
Yes, ma'am.
Okay. Now coming to the today's topic, that is your three-phase. Okay. So these three-phase circuits, basically, I told you yesterday, we also call them as polyphase systems, or we call them as three-phase systems. So we can say this thing I also told you, that in case of electrical power generation, all the transmission system in the world, that is three-phase system, that I had discussed with you yesterday also, that if you talk of any system in which the generation takes place, so that generation is always of we can say uh, three-phase generation. Whenever you talk of the generation, that is a three-phase generation in that case. Okay, so that case we call it as a three-phase generation. One more thing, in case of three-phase systems, that one more discussion we had done yesterday, that we can go for three single-phase systems as compared to single three-phase systems. That also we can do. ये हम कल पढ़ चुके थे. But the difference over here, or we can say the advantage of using, are both the files of mine visible, or only one file is visible to you? I've just opened two files. How many files are visible?
Currently, only one is visible.
Only one is visible.
Only one
Okay,
is visible.
okay, just a minute. I'll do the other one. Okay, actually, I just want to make you clear this thing also. See, we had discussed two things yesterday. One, I told you we have one single phase system, and we can use three single phase systems to make a three phase system. And we can have a single three phase system also. These two things we had discussed yesterday. Now, there are certain, we can say, advantages of, we can say, using a three phase system, which is a single three phase system, over uh, using a three single phase systems in synchronization. We need to synchronize them. Do you know what is synchronization?
No, ma'am.
We need to synchronize. Means, say for example, okay, whenever you will come to the campus, okay, when you will come to the campus, boys and girls, they'll be staying in separate hostels. Okay, so if you will be given some choices, will you be, we can say, interested in choosing your room partner?
Yes, ma'am.
Yes, ma'am.
Okay, na? Everybody, if you will be given the choices, you will be obviously. So there will be one synchronism, there will be one mechanism based on which you people will be choosing that he is my roommate, or a girl will be choosing that she is my roommate. Is it clear? So there will be certain we can say conditions. What would be those? Say for example, you would be of the same place, you would be knowing each other, you will be of same nature, something like that. Means there should be some synchronism between the two, we can say, mates who will be living in a single room. Is it clear?
Yes, ma'am.
Similarly,
Yes,
Yes,
ma'am.
ma'am.
these three phases need to be, we can say, working as a three phase system. These three single phases need to have certain synchronizations, they will be connected in parallel, say, there should be one synchronization. Say, for example, the voltage ratings of all of them should be same. The frequency, of course, that should be same. The we can say the phases will be of course same. So there are certain, we can say, conditions which all of them, all these three phases need to we can say satisfy. Then they can be used as a single three-phase system. That is fine. But in addition to this will be done. Okay, this all is done. But after that also we can say that a single three-phase system will be much more advantageous as compared to that of three single phase systems, in a way that firstly the material being used, we can say, that can be we can say in a very judicial manner in case of three phase system. Secondly, the efficiency, of course, when they need to work in synchronization, their efficiencies, they would matter. And if it will be a single three phase system, that efficiency would be much better as compared to that of a three single phase systems. Okay. This is one more thing. More. That is why we prefer a single three-phase system. Is it clear
Yes,
to
ma'am.
everybody? What is the need of three phase?
Yes,
And one
ma'am.
more important thing that I told you, the most of the generation which is being done all over the world, in the world, that is being done in form of three-phase AC system. One more thing, do you have any idea? Can we generate DC? It is a form of energy which is स्टोर, जैसे आपकी बैटरीज में हो गई, आपकी इन्वर्टर में हो गया, that is all we can say form of energy which is stored, okay, which is being generated and transmitted is, is
AC.
it clear to everybody? ठीक है. Okay, now coming to the next part of it, that this was how, why we can say why we prefer the AC systems, or what is the requirement of three-phase systems, that we have discussed. After that, now now coming to one more thing we had discussed, that was the generation of three-phase system that we had discussed yesterday. So generation of three-phase systems, or in a, we can say, single phase generator, all of us know that comprises of three single phase generators with voltages of equal amplitudes. ये मैंने आपको कल बताया था ना, VP, that is the voltage, or VM, that is the voltage, that will be equal amplitude, but there will be phase difference
120.
of 120 degrees. If it must be clear to you, is it clear, or I should write it?
Clear.
क्लियर है ना. तो सबसे पहले आप
Clear.
देखो फेज वन. अब एवरीथिंग इज डिपेंडेंट ऑन दिस ग्राफ. यू जस्ट try to understand. I'll just make it again. I'll try to make this graph, but you just understand this graph. In this graph, the voltage and this is time. Now if you can see the first graph, it starts from 0, that is VAT, this one. Okay, this is one phase. That is this VAT, whose value is equal to under root of 2. We take it as RMS value and the maximum value. That's why it's written under root V sine theta. So it's under root V 2 V sine omega t. ठीक है, this much of volts, or we can say VA is equal to V angle 0 volts. Is it clear to everybody? So that is the voltage of this phase. That is the first line. Now comes the next line, which is some degrees. If you can see, is it 120 degree clear to you? This is 90 and this is 120. So that means next graph is starting at an angle of
120 degree.
120 degree apart, means
20.
VB. Now coming to VBT. VB is the voltage across RYB bolo, ABC bolo. These are phases. So second phase, the voltage of that phase is starting from an angle of, we can say, delay of 120 degree. So it is writing VBT is equal to under root 2 sine omega t minus 120. Is it clear? Or we can say VB, that is the voltage across the next or the second, we can say this phase, that is VB equal to angle minus 120 volt. Is it clear now? That means the second graph is starting from this point, that is 120 degree apart. Is it clear? That is the second one. Third, I told you it will be again minus 120. That means it is minus, या हम कह सकते हैं इसको plus 120, या क्या बोलेंगे minus 240. That means it will start from here. So this is the third one. Is it clear?
Yes,
Is the
ma'am.
graphical representation of the three phases clear to everybody?
Yes, ma'am.
सबको समझ आ गया? And these three expressions, I'll again write it for you so that you would be able to understand it well. I'll again write it. I'll try to communicate it to you in a different manner. So, if you see, just now we have discussed about the three phases that I told you. One will be VA, one will be VB, all of them will be dependent on T, and another will be VC. Is it clear? These are the three phases, voltages. Now we'll again draw a graph between the voltage and here it will be T. So starting from the first one, that is A, it will be something like this. Is it clear? So here angle is 0. So it will be V root 2 बोल दो या VM बोल दो या VP बोल दो, something like that. Angle 0 degree. Is it clear?
Yes, ma'am.
Next, we told it will be starting somewhere from 120 degrees. So somewhere here, that means this is VB. It will be equal to now, बताओ VP, magnitude
120.
will be same. Yes. This, it will be somewhere. You can just join it over here. So it will be somewhere here. So that will be starting from. ठीक है? Is it clear to everybody now? So this will be. अब ये समझ आ गया सबको?
Yes, ma'am.
ठीक है ना? सबको क्लियर हो
Yes,
गया?
ma'am.
Okay. So now this was about the, we can say, the relation of, we can say, relation between the three phases of a three-phase circuit. That was the relation. Fine. Now coming to the next part of it, that is impedance. If you talk of again, that will be the same thing. We can say the impedance or the current flowing through. One thing I told you of balanced load. Balanced load, I told you when all the three phases will be having the same load across them. That means the current will be same because Z will be same. है ना? That means I is equal to V upon Z. Okay. So it will be same in all the three phases. Now, okay. Now coming to the next. This is that that I am talking of the current. So if you say the current flowing in each phase, and if the if we talk of the balanced system, so here we can say if you talk of a balanced system means in which all the we can say load in all the three phases that will be same, or we can say load of the three phases will be same. So in that case we can say it is a balanced system. Okay. And in that case IA, IB and IC, yeah, it is IC, it will be the current flowing through all the three phases. Okay. So that will be V upon Z, V upon Z, of course, but only difference will be again in angles. Amplitude of current will be same. Is it clear to everybody?
Yes, ma'am.
ठीक है?
Yes, ma'am.
Yes, ma'am. Yes,
Okay,
ma'am.
so we can see now any ये जो आपका थ्री फेज सिस्टम है, जैसे मैंने आपको वोल्टेज की बात बोली थी या करंट एनीथिंग यू कैन से, in that we just need to see that summation of all the three, we can say, currents flowing in these, we can say, in the three phases, the summation should be equal to zero. Summation should be equal to
Zero.
zero. Okay, then it will be a balanced system. Now, one more thing which we need to understand in this is the phase sequence. That is a term which we very frequently use in this, we can say, three phase system. That is the phase sequence. इसको ध्यान से सुनो. सबसे पहले we said in case of balanced system, we talk of the loads will be same. Okay, and आगे हम पढ़ेंगे how these loads are connected, what is neutral, वो हम अभी पढ़ेंगे आगे. Before that, I need to tell you about the phase sequence. What do you mean by phase sequence? I told you that there are three phases. That is clear to everybody. Is it clear that
Yes,
there are
ma'am.
three
Yes, ma'am.
phases? I told you one phase, in a three-phase system there will be three phases. Phi stands for phases, and they can be named as A, B, C. Sometimes it is written as R, Y, B. Any of the name or the nomenclature can be given, and only if it is taken as ABC, and when you say the order of the voltages in those, we can say, peaks, that is in sequence of A, B and C. That means it will be first A in clockwise, then B, then C. If such kind of sequence is followed, if such kind of sequence is being followed, in that case we will be saying that it is a positive phase sequence. Okay? If it is like this, or the phase sequence can be other ways. It can be anti-clockwise. It can be A, C, B. If it is A, it will go like this. C and B. It will be something like this. Means one is clockwise, one is anti-clockwise. ये क्लियर हो गया सबको?
Yes, ma'am.
ठीक है, फेज सीक्वेंस. अब ये फेज सीक्वेंस क्यों इंपॉर्टेंट है? बिकॉज अगर हम फेज सीक्वेंस के वे से चलेंगे, इफ यू गो बाय द, वी कैन से, सीक्वेंस, हियर दिस दीज एंगल्स मींस इफ इट इज बी ए देन इट विल बी जीरो. अगर अब बी है या सी है, इट विल डिपेंड दैट व्हाट विल बी द वैल्यू ऑफ दिस 120 डिग्री. इज इट क्लियर? दैट इज व्हाई फेज सीक्वेंस इज इंपॉर्टेंट. क्लियर टू यू और नॉट? ठीक है.
Yes,
Yes,
ma'am.
ma'am.
Okay.
Yes,
Now
ma'am.
next comes that how these three phases are connected to each other. Now comes the application of स्टार एंड डेल्टा. हमने पढ़ा था ना स्टार एंड डेल्टा, उसका क्या मतलब था? what was the fun of, we can say, using those three connections either in star way or delta way? Here comes the application of star delta connections. Now we can see there are two ways in which these three phases can be connected to each other, or these connections in the three phases can be done. Okay, and those type of connections in which three phases can be done, those are star and delta that we have discussed already. We know what do you mean by a star shape. It will be something like this Y shape, and if it is delta, it will be something like this. ये तो सबको पता है ना?
Yes, ma'am.
Okay,
Yes, ma'am.
so now
Yes,
we
ma'am.
can see over here in case of three-phase circuits, the connections, or we can say the uh, ways in which the circuits can be, uh, we can say, connected to each other. That can be done either in star way, or it can be done in delta connected circuits. These are the two, we can say, combinations, or these are the two things in which the uh, compositions or the changes can be done. Fine. This is how it can be done. Now I'll be showing you just a minute. So this is, these are the two type of connections. First is your star connection that we have discussed. Now here there will be some difference in the two. Can you tell me if you have understood the, we can say, star and delta connections? You can tell me the difference, how it will matter, or how the difference in star and delta can be there. Can anybody tell me? We have taken, say, for example, the resistive load over here. Can anybody tell me what will be the difference in star and delta connection with
There would
respect to,
be,
say, for example, currents? कोई बता सकता है मुझे? एक जनरल
At
सी
that
बात है.
nodes, the current would be same, whereas in the delta there must be division of currents in other
Yes,
branches also.
yes, yes. That is the difference. Now I will just show you this. See, in this particular connection, which is a this, you can see there are two things here which we will be coming into, which we'll be frequently discussing. One is the line current, another will be the phase current or voltage for that matter. We'll talk of current. Okay, two things we will come into contact, or we will be discussing about two things, that is the line current and the phase current. Okay, so now coming to what it actually means. Actually, there are three phases, that is clear to everybody, and the point at which all of them are connecting, that is a neutral. Is it clear to everybody? ठीक है,
Yes,
Yes,
ma'am.
ma'am.
ये सबको क्लियर है ना? हम कह रहे हैं there will be three phases and one point at which all of them will be, we can say, joining that particular phase we call as the neutral one. That is okay. Next, this is your phase and this is your neutral. In case of star connection, if you can see, the same amount of current will be coming from the line which will be going to the phase. Is it clear? है ना? But if you see the same thing in a delta connected circuit, just yes, here you can see at this particular node, will this current from the line be bifurcated or not? Change हो जाएगी ना at this node?
Yes, ma'am.
Ma'am.
That is the difference you need to understand between star and delta. अगर हम यहाँ पे IL की बात कर रहे हैं, it will be here divided into, say, IAB and ICA. Is it clear? इसको हम डिटेल में करेंगे, बट आपको बेसिक डिफरेंस पता चल गया
Yes, ma'am.
yes,
है ना?
ma'am.
दैट इज द
Ma'am.
मेन डिफरेंस बिटवीन, जो मैंने आपको बताया, लाइन करंट एंड फेज करंट in case of delta and star. Okay, in case of delta and star, this is where the difference lies for star, or we can say for line current and phase current. So we will be starting again from the star connected circuits. Now see, here will be IL and IA, that is the line current and the phase current. Now coming to the voltages, we will be taking the voltage across which? Across 2 points, across two potential will be taken across 2 points. So if you talk of A, this is A line, this is B and this is C. If you talk of the voltage between A and B, what it will be? This will be VAB, hoga na? But
Yes, ma'am.
here, if you talk of the voltage of this line, it will be between this potential and neutral point. होगा कि नहीं? That means it will be VAN.
And
N is the neutral point we are taking over here. So it will be VAN. Next, across this B, it will be B and N. मतलब इस point के बीच में और इस point के बीच में होगा, which will be VBN, जो ये बताया हुआ है आपके voltages और potentials. Next will be VCN. तो ये दो voltages different होंगी ना? One will be between phases, one will be between line and the neutral. So this is your line voltage, this is your phase voltage. ये समझ आ गया?
yes,
Yes,
ma'am.
ma'am.
डिफरेंस समझ आ गया ना? ओके, सो हियर वी कैन से इन केस ऑफ, अब ध्यान से सुनना, इन केस ऑफ स्टार कनेक्टेड सर्किट्स, द लाइन करंट एंड द फेज करंट, दे आर सेम. ठीक है, ये क्लियर हो गया सबको?
Yes, ma'am.
बट इन
Yes, ma'am.
केस ऑफ स्टार कनेक्शन, द लाइन वोल्टेज एंड फेज वोल्टेज, दे आर नॉट सेम. नहीं है ना सेम? एक न्यूट्रल के बीच में है और एक दो लाइंस के बीच में, वो दोनों वोल्टेजेस डिफरेंट है कि नहीं है?
Yes, ma'am.
Yes, ma'am.
ठीक है, समझ आ गया? Now, we need to draw the relation between them also. If you can see, the current in any line is same as the corresponding current in that phase in case of star connected. This line is clear to everybody? Just read this line. Everybody, is it clear to everybody? This line is clear to everybody?
Yes,
Yes,
ma'am.
ma'am.
ओके सो ये आपने याद रखनी है और समझनी है. You need not to forget it, this line and this expression in case of star connected circuits. The line current, or we can say current in any line, is same as the current in the corresponding phase. That means in case of star connected circuit, IL is equal to I phase. सबको याद हो गया? ये समझ आ गया? पहले अगर समझ आ गया तो याद हो जाएगा. याद होना इज नॉट अ बिग डील. समझ आ गया एवरीबडी?
Yes, ma'am.
Yes, ma'am.
नाउ
Yes, ma'am.
नाउ कमिंग टू द वोल्टेज. तो ये लाइन आपने याद रखनी है. इफ एनीबडी एनी टाइम आस्क यू, उसके लिए आपको प्रिपरेशन की जरूरत नहीं पड़नी चाहिए. यू नीड टू रिमेंबर इट, बिकॉज इफ यू विल अंडरस्टैंड इट, इट इज वेरी इजी टू रिमेंबर. सो हमने देख लिया है, द सेम करंट कमिंग फ्रॉम दिस लाइन goes to the phase. That means the line current and phase current are same, simple. Now coming to voltages, VAB मैंने आपको बताया between A phase and B phase. This will be, make it a bit, is it clear now?
Yes, ma'am.
Yes,
ठीक है ना?
ma'am.
This is between A and B. This is VAB, that is the phase voltage. Now coming to this voltage, now we will see the relation. This thing we are clear now that the two voltages, they are not same. Now we need to see the relation. What is the relation of the voltages between the two? They are not same, that we have discussed. Now what is the relation? Now we say VAB, वो आपको पता चल गया कौन सी वोल्टेज है. That will be A minus B. That means there is V5 angle 0 minus VA कौन सी है? V5 angle 0 minus VB कौन सी है? V5 angle 120. Is it clear to everybody?
Yes, ma'am.
अब हम V5 को कॉमन ले लेते हैं. It will be minus of 120, 1 by 2 V5 minus J in terms of its rectangular components, and root of 3 by 2. That means it will be simply, we can say root 3 by 2 plus J 1 by 2, or it will be root 3 V phase with an angle of 30 degree. Is it clear?
Yes, ma'am.
relation between, ये कौन सा है आपका? फेज वोल्टेज एंड लाइन वोल्टेज. ये लाइन वोल्टेज, ये फेज वोल्टेज. इज इट क्लियर? Line voltage is root 3 times phase voltage. ये क्लियर हो गया सबको?
Yes, ma'am.
Yes.
कैसे हुआ बिल्कुल आपके सामने है. सिमिलरली वी कैन गो फॉर अदर फेजेस. VAB हो गया ना, वी कैन गो फॉर VBC, वी कैन गो फॉर VCA इन द सेम वे. ये क्लियर है सबको कि नहीं?
Yes, ma'am. Clear.
अब उसमें फेज देखो, फिर आपको बताया था ना, इसमें मैग्नीट्यूड सेम रहेगा. हियर आल्सो यू कैन सी मैग्नीट्यूड ऑफ ऑल ऑफ देम आर, but where does the difference lie? In the,
Please.
अब आपको 30 डिग्री का लैग हो रहा है ना. माइनस था ना वो, 30 डिग्री हो गया. फिर माइनस 120 को माइनस 90, 240 माइनस 30 हो गया 1 to 10. इज इट क्लियर?
Yes,
सबको
ma'am.
ये चीज क्लियर हो गई सब अच्छे से? ओके, सो दिस इज हाउ वी कैन फाइंड द, इसे हम कहते हैं रिलेशन between, if you are asked to find relation between phase voltage and line voltage. So this is the relation between phase voltage and line voltage. Is it clear to everybody? In case of star connected systems. Clear to everybody?
Yes, ma'am.
ठीक है ना? तो
Yes,
अब
ma'am.
यही चीज हम लोग और देख लेते हैं. इस लाइन को याद रखना. पहले हमने करंट की लाइन को याद रखा था. Now we can say magnitudes of line to line voltages and line to neutral voltages are related as. So this is line to line बोल दो या line voltage बोल दो, ये आपका phase voltage. Magnitude, angle हमने देख लिया. There was an angle of lag of 30 degrees. But magnitude में क्या difference है? Line voltage is root 3 times phase voltage. ये सबको समझ आ गया?
Yes, ma'am.
Is it clear to everybody? So you need to
Yes,
remember
ma'am.
this.
Yes,
In
ma'am.
case of current, in case of this star connected, IP is equal to IL, or we can say I phi is equal to IL. But in case of voltage, VL is equal to root 3 times V phi. Clear? तो ये magnitude था. This was about magnitude, याद रखना. Now if you talk of this was about magnitude, याद रखना, this is only magnitude. Now, if you come to the line to line voltages and their, we can say, respective phases, we have seen that there is a phase shift of 30 degree with respect to the phase voltages that we have seen. अब इस डायग्राम को ध्यान से देखो. दिस इज वी ए बी. सब लोग देख रहे हैं कि मैं ऐसे ही बोले जा रही हूँ?
Yes, ma'am.
Yes,
देख
ma'am.
रहे हो ना? ध्यान से देखना. दिस इज वी ए बी. यू कैन ड्रॉ इट ऑल्सो. आई गिव यू टाइम. दिस इज वी ए बी. दिस इज वी बी सी. ये एक 120 डिग्री अपार्ट है ईच अदर. ये और ये तीन देखो आप. दिस इज वी ए बी. VBC is 120 apart. VCA is 120 apart. Clear? Now coming to the, this was about the these between the lines. Okay. Now coming with the phases, with the neutral, we can say. So this is VAN, means there is an angle between VAB and VAN of कितना 30 degrees.
30.
ठीक है. Now coming to next, VBC or BN, that is the B phase and neutral. So there's an angle of 30 degree between them. Again, coming to VCA, that is C and A, between these two lines. So what about the, with neutral, there's an angle of 30 degree. Is it clear now to everybody?
Yes, ma'am.
ठीक है ना? तो ये फेजर आपने याद रखना हमेशा. You can draw this also, this phasor, in which you can see the the difference in the angle between phase voltage and the line voltage, V phi and VL. Okay, that we can see here. It is at an angle of, or we can say there's a difference of 30 degree which is being maintained between every line and phase. You want to draw it?
Yes, ma'am.
Okay, कर
Yes,
लो.
ma'am.
आराम से कर लो. I'll wait for you. पूरा लिख लो इसको. मैं आपको क्लियर ले. And if you want to write down before this also was completed, then I'll give you the. Okay.
Excuse me, ma'am.
Yes, बोलो बेटा.
Ma'am, I have little doubt in the
हाँ जी.
line phase current.
बोलो बेटा.
मैम जैसे इसके अंदर फेज करंट, इसके अंदर भी तो मैम बाइफरकेट हो जाएगा इस पॉइंट पे आके,
कहाँ पे?
नीचे पॉइंट पे.
देखो बेटा, ये फेज आपका, ये देखो, ये आपकी लाइन है ना.
यस मैम.
सेम ये आपका फेज है. सेम करंट जा रहा है इसके अंदर. यहाँ पे तो कहीं डिवाइड नहीं हो रहा है ना. Till this point. उसके बाद तो अगला स्टार्ट हो गया ना. तो सेम करंट जो यहाँ से आ रहा है, दैट इज गोइंग टू दिस.
यस मैम.
समझ आ गया? अब अगर डेल्टा लेंगे, अब देखो डेल्टा. अब इसमें देखो, ये आपका एक फेज है, ये दूसरा है, ये तीसरा है. ये ठीक है ना? अब देखो जो यहाँ से करंट आ रहा है, वो इस पॉइंट पे, ये अलग अलग फेजेस है. कुछ यहाँ जा रहा है, कुछ यहाँ जा रहा है. तो डिवाइड हो गया ना?
यस मैम.
अब समझ आई?
हाँ जी मैं न्यूट्रल पॉइंट के लिए कंफ्यूज हो गया था.
नहीं, न्यूट्रल पॉइंट तक तो आपका फेज हो गया ना. यहाँ से आपका अगला स्टार्ट हो गया ना. यहाँ से अगला स्टार्ट हो गया. ठीक है?
ओके.
Okay. Now we will come to delta. Star is clear to everybody?
Yes, ma'am.
समझ आ गया? तो ये डेरिवेशन आपको पूरा आना चाहिए. समझ आ गया ना आपको? सिंपल सी बात है. ए बी है, वी ए माइनस वी बी, एंगल वी फाई. तो आप सेम तीनों का ले सकते हो. और अगर आप इस तीनों के वोल्टेजेस को सम करेंगे, वी ए बी प्लस वी बी सी प्लस वी सी, दैट शुड बी इक्वल टू 0. Now coming to the next, that is डेल्टा कनेक्शन. अब आप डेल्टा में देखो. डेल्टा में आपकी सेम, फॉर एग्जांपल वी हैव टेकन रेजिस्टिव लोड. Okay, now in case of delta, if you see the current, that is A current, or in the A phase, it is coming at this particular point, and here that current is being bifurcated, we can say. This current is being divided, we can say, into IAB and ICA. Is it clear? AB and CA. Clear to you?
Yes, ma'am.
अब अगर आप करंट की बात होगी, अब अगर आप वोल्टेज की बात देखेंगे, ये आपका एक फेस है, ये बी है. अब इन दोनों के बीच का पोटेंशियल देखेंगे आप, है ना? तो ये होगा आपका वी ए बी. होगा कि नहीं? इफ यू सी, The same is the potential between these 2 points. है कि नहीं है?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
समझ आ गया?
Yes,
अब
ma'am.
इनके डेल्टा क्या होगा? VL is equal to V5, है कि नहीं?
Yes, ma'am.
Yes,
And
ma'am.
Yes, ma'am.
IL is not equal to I5. Is it clear what is line voltage and what is phase voltage?
Yes, ma'am.
Yes, ma'am.
अब हम इसका डेरिवेशन देख लेते हैं एक बारी. Now this is about the we can say delta connection, and in case of delta connection again we can say IAB is equal to I angle phi, BC is equal to this, and ये तो हमें पता ही है, and IC is equal to I angle minus 120. This we all know. Now coming to the in case of voltages it is same, so we need not to bother for voltages. So this is your line to line voltage magnitudes are same in case of phase voltage. This is clear. Now, where the difference lies in case of current, that we need to discuss now. तो आप ये लिख सकते हैं, in case of current IA, that is the current in phase A, which is equal to IAB minus ICA. Is it clear? So we can put the values of AB and CA, which is simply I angle I phi हम कह सकते हैं, या I phase. Sometimes it is written IP also. Different nomenclatures are there, but it is the phase current. I phi angle 0 degrees minus I phi angle minus 240 degrees. So it will be again root 3 times phase or angle of minus 30 degree. ये समझ आ गया सबको?
Yes, ma'am.
Clear to everybody? So we can just replicate this thing. IA we can replicate to IB as well as to IC. This is clear. And यहाँ पे if you see the phase angle कितना difference आ रहा है? minus 30 degree. तो वो minus यहाँ से हो गया 150 और यहाँ पे plus हो जाएगा plus 270. ये clear हो गया सबको?
Yes, ma'am.
Yes, ma'am.
So magnitudes of line and phase current, they are related. IL is equal to root 3 times I5. Fine. और what about the angle? जो हम जैसे हमने वहां पे किया था वैसे ही we will discuss the angle over here. So angle will be again first taking the three currents. This is your IAB, this IBC and ICA. ये आपकी तीन currents आ गई. ठीक है? Now seeing the angle, it will be lagging by an angle of 30 degrees. That means इन दोनों के बीच का lag जो होगा वो कितना होगा? minus 30 degree. तो IAB और IAA के बीच में. Similarly, IBC or IB lagging by an angle of minus.
T.
Similarly, ICA or IC lagging by an angle of minus. ये clear हो गया सबको? तो हम क्या बोल सकते हैं? For the connections with ABC phase sequence, ये याद रखना है, phase sequence is important. So we are taking it in clockwise direction A, B and C. So ABC phase sequence is there. So current of a line lags the corresponding phase by an angle of. ये समझ आ गया? Everybody, is it clear?
Yes, ma'am.
Yes,
Ma'am.
ma'am.
Yes,
Yes,
ma'am.
ma'am.
So these two things are clear to you. हम इतना ही पढ़ेंगे आज, just to revise it up. So what we have discussed today is about the connections that are being used in the three-phase circuits. That is the star connection and delta connection. In case of star connection, we have seen the line current and phase current, they are same. But in case of voltages, they are not same. Phase voltage and line voltage, they are related to each other by an angle of we can say root 3 times the line voltage, this phase voltage. And in case of the delta connected circuits, the voltages, that is phase and line voltage, they are same. And line current and phase current, they are related to each other. Line current is equal to root 3 times phase current. Is it clear to everybody now?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes,
है?
ma'am.
तो
Yes,
सब
ma'am.
लोग इस चीज को आज पढ़ेंगे. इसको डेरिवेशन को लिखोगे आप, तीनों फेजेस का निकालोगे. हमने यहाँ पे आई ए के लिए निकाला, आई बी और आई सी के लिए भी निकालोगे. एंड यू विल राइट ऑल दिस इन योर कॉपीज. ओके, क्लियर?
Yes,
तो पॉइंट इसका फेजर भी जो ये ड्रॉ किए हुए हैं दो फेजर, दिस ऑल्सो यू